This is Unit 3, Matter, Lesson 3, Particle Diagrams, Practice Your Skills Answers. Do now. Describe the separation technique that could be used to separate two colorless liquids with varying boiling points. So the key words in this question are the colorless liquids and the varying boiling points. So a lot of times you might think that evaporation is a good choice. However, because we have two colorless liquids together, distillation is actually the best choice because they'll both have they'll have different boiling points, and that different boiling point is the physical property that will allow us to separate those two liquids. Evaporation is a better choice when you have a solution, such as sodium chloride dissolved in water. 2. What type of separation cannot be used for a homogeneous mixture? So your keywords here are cannot be used for homogeneous mixture. So all the separation techniques that we talked about in our previous lesson, with the exception of filtration, were for homogeneous mixtures. So filtration is the only separation technique used for heterogeneous mixtures, such as sand and water, or something where you have uh, where you can filter out like coffee grounds and coffee. Okay, the particle diagrams. I answered this in the Ed Puzzle, so make sure you watch this video. Here are the practice your skills questions. So each of these particle diagrams are examples of either an element, a compound, a mixture of elements, a mixture of compounds, or a mixture of elements and compounds. So I would like you to try and give some examples, but you don't have to actually. If you couldn't think of anything, the idea was, for example, C, this is a compound, and I wanted you to think, well, maybe that's H2O because it's got two H's and an O. So just take a look at these. I gave a couple of examples, but it's not required because I didn't do them all either. Okay, in terms of composition or types of atoms, what is the difference between a monatomic element, a diatomic element, and a diatomic compound? So I think this is a little confusing for some students. A monatomic element is composed of only one atom. A diatomic element is two atoms of the same element combined, and a diatomic compound is a compound with two different elements. So here are some examples of particle diagrams. So you should be able to draw particle diagrams based on whatever it is asked for. Because here are some regions practice where you would be expected to do that. So I know my circles aren't super good, but here is one Z and two X's for each of those. And then here are those examples. Now remember remember the word homogeneous. I always write over the word. This means uniform or the same throughout. So you're going to draw them as if they're all spread out evenly. So do your best to make it look like it's all even. All right, and here are some examples of actual real world substances and how we would classify them as either an element, a compound, a heterogeneous mixture, or a homogeneous mixture. So milk is technically truly a heterogeneous mixture. However, the particles are so fine that you may not recognize that. One way that I want to make sure is clear to you, a heterogeneous mixture, if I let it sit, so for example, if I have a mixture and I let it sit for a while, if it separates, then that's an indication that it's heterogeneous. If I let milk sit for a while, you'll get a little film at the bottom of your container, and that's where some of the small particles are settling. Settling. Separates or settles. So those are key words also for heterogeneous mixtures.